Hi, welcome. In this video, we will solve first unique character in a string problem asked by companies like Apple, Bloomberg, and Goldman Sachs.
Now let's check out this problem statement. Okay. First unique character is in a string. Okay. Again, one very famous problem statement. So given in a string is S, so this is S pro prep. Find the first non-repeating character in it and return its index. If it does not exist, return minus. Very straightforward problem statement. Okay. And so here you can see we have pro prep as in string. Okay. So if I see that P is also repeating here 3 times, R is also repeating here 2 times, O is not repeating. So if I take the index of O, that will be 2. That's why the output is 2. And here for progress, so P is the first letter that is not repeating. So that's the index is 0. That's why the output is 0. Now let's see how we can solve this corner statement. So we have what is our string, that is so I'm writing all this in a small letter. So we have pro prep. Okay, this is my string. Okay, and in the problem statement also, like here, this will be in a small letter. So let me put it in this. So we have in this string pro prep, and let me write the indexes as well: 0, 1, 2, 3, 4, 5, and 6. Okay, so what we can do, how we can approach this problem statement. So one of the very basic approach, that is, you can see the brute force approach, can be that we write pro prep. Okay. And I will take one character, that is P, and I will find the count of that character. Okay. So if I will find the count of that character, like here, that will be 3. So what I will do, I will ignore it. I will simply move it. Okay. Then I will check R and I will find the count of the character. What is the count? Again, I will start from 0. And what is the count of R? So I will move forward, and I will say, oh, here are 2 counts. So I will again move. I will put count equals to 2. Okay. And here count is 2. So I won't take R as well. Right. I will move forward and I will check O, and I will again start from 0 count, and I will check again from here itself that what is the count of O. Okay. So even like if the count of O is already there, right? So we can simply eliminate O at that time itself. So here you can see the count of O is simply 1 if I'm starting from here, right? So now what I will do, that O is my letter, and I will simply return its index. So 0, 1, 2, I will return 2. Okay. So what you are taking, you are simply sticking to the one element. You are fixing one element, and you on the rest of the elements, you are searching of like a similar element. Okay. So there can be chances that count will be 0 or 1. 0 if when you are not including that element. So if I'm not including that element, it will be 0. If I am taking that element, it will be 1. Right. So it again depends on you how you will solve it. Yeah, similar, a little bit tweaks will be there. But yeah, this will be one approach. And by this approach, when we are fixing, so basically how you will do it, you will take one loop that will start from 0 and that will run to n. Okay. And one more loop that will start from, I will say, either can be I to n or I plus 1 to n. Okay. So if it is I to n, so you will take count 1. And if it is I plus 1 to n, so it will be 0. Okay. So like here, if I'm taking I, so I can mention with 0 because I'm taking I. So I will check that correct. I can mention it 0. And if my character, right, suppose this is my string, the string of I is equals to string of J. So what I will do, I will simply count it, count plus plus, and in the last I will simply say if count is equals to 1, 0, simply that this is my unique element, and I can simply return it, return the index. But this approach Okay, why I'm not discussing so much about this approach? Because this is the brute force approach, and the time complexity, we mentioned it here. The time complexity of this approach will be big O of n square, right? Because this will also take n times, this will also take n times, right? So the total time complexity will be n square. Okay, space complexity will be constant because we are not taking any extra space, right? But we need to optimize it, right? We need to find out a better version of it. Your interviewer won't be happy by or this solution, right? So what we will do? So we will figure out some different approach. Again, let me take the string as pro. Yep, this is my string. Okay. And eventually next is, so what we can do here? So again, we need to find the first non-repeating characters. Non-repeating. Okay. So can I say this non-repeating characters giving me a sense of something as I need to find frequency? That how many times this character is appearing, right? So what I will do, I will create a hash map, or simple an object. So I will create an object. So this will be my object. Okay. And here I will simply store the frequency of all the elements, right? So what I will do, I will first go through all the elements. I will take P is defined, so that will be in key and value pair. Okay. You can see this is my object. So is P is defined in the object? No, it is not. So I will define it with the value 1. I will move forward. The R is defined in my object, So I will simply define it, the value of 1. Is O is defined in my object, I will define it, the value of 1. Then is P is defined in my object? Yes, it is. So I will update the frequency. Okay. And I will check R is defined in my object. Yes, it is. I will update the frequency to 2. And then I will check is E is defined in my object. No. So I will define it. And then I will check is P is defined. Yes, it is already defined. I will update the frequency of P. Okay. And now what I will do, I will take characters one by one of my string. Right. So I will check P. Is P is defined? Yes, it is defined. What is the frequency? 3. So I won't take it. And I will check is R is defined? Yes. What is the frequency? 2. So I won't take it. Then O is defined? Yes. What is the frequency? 1. Yes. That is the frequency that I want. And what I will do, I will simply print the index, that is print or return. Okay. And that will be my answer at this 2. So this is how you can solve this problem. Let's take one more example. Okay, so what was our one question, that is progress, and let's quickly understand this as well. So suppose we have one string as progress. Okay, again let me write the indexes 0, 1, 2, 3, 4, 5, 6, 6, and let me create an object for it. This is an object. I will check space defined. First of all, key value pair object is piece defined. No, it is not. Put the frequency 1. That is defined. No, it is not. I will define with frequency 1. Who is defined? No, it is not. I will put the frequency with 1. And G is defined. The frequency with 1. Then is R is defined? Yes, it is. So I will update the frequency. Then is E is defined? No. So I will add with the frequency 1. So is S is defined? No, in the object. I will define with the frequency of 1. So again, S is defined. Yes, it is defined. I will update the frequency with 2. And that's it. That's the end of the loop. Okay. Again, I will come back and I will check each letter. Is P is defined in my object? Yes, it is. What is the frequency of P? That is 1. Okay. So that will be my answer. So here I can simply return a element that I'm starting that has a frequency of 1. So that will be my answer. Answer will be 0. So this was approach 2, where we can solve this problem using hash map. using hash map, or you can say using objects. What will the time complexity of this approach? What will the time complexity of this approach? That will be, so you are iterating through the string, so it will be go of in the space complexity here, because you are taking one extra space, that is your object. Okay, and if there are all unique elements, so the space complexity of your object, yeah, space will also take n of elements, right? So the space complexity will also be big of n. Okay, now let's see one another method that we have also discussed, where we don't need to take an object, but instead of creating this space, we can create a constant space. Right? So let's check that method. So in the next method, what we can do, we can create one space, right? One array space here. Okay. So this is my array basically of 26 elements, right? So I will say this is my array of 26 elements. Why 26? Because alphabet has 26 letters. Okay. What I will do again, I will take one string here. Okay. And that is pro prep. Okay. And these will be my indexes 0, 1, 2, 3, 4, 5, 6. Okay. And then I will take each letter of my string one by one. Suppose I am taking P, right? So I will find the ASCII value of P. What is the ASCII value of P, right? So if I check, the ASCII value of P will be 112. Okay. So what I will do, I will check the ASCII value. Okay. And I will subtract this ASCII value with the first letter, that is A. Okay. P, let's take P as in small. P, it is not capital. P is, so P is small p in a function like this. P ASCII value subtracting with A ASCII value, we will get the index here. Right. Let's see what is P ASCII value. That is 112. And what is your A ASCII value? That is 97. So 112 minus 97, that will be your 15. Okay. So what I will do, I will simply move to the index 15. I can directly move it, right? Array of 15. And I will update with the frequency of 1. Similarly, what I will do, I will move to the next statement. I will find the R ASCII value. Okay. Minus A ASCII value. What is the R ASCII value? So the R ASCII value is 140 minus 97. That will be 17. And simply move to 17 and will update the frequency of 1. Similarly, I will go to O. Okay. O ASCII value minus A ASCII value. What is O ASCII value? That is 111 minus 97. That will be 40. Okay, so I will simply go to 40 and did the frequency of O. Similarly, I will again check. So there is the same letter P, right? This will be 15. And I will update 15 with the one frequency, that is 2. Then I will check new letter, that is R. R, what is 17? So I will update 17 with the frequency of 2, because that is already done. Then I will get E. What is E ASCII value minus A ASCII value? So E, we all know that is 101 only, minus 97. So that is the fifth letter. Okay. So we are starting from 0. So that's why it will be comment 4. So that's the fifth letter. 1, 2, 3, 4, 5, A, B, C, E. Right. I will update the frequency. So the frequency will be 1. Now we have again P, right? So P minus A and give 50. So what I will do, I will simply 50 and update the frequency with 3 now. So in the final, I will have some structure like this, right? So 14, what is 14? That is O with one frequency, then E with one frequency, P with three frequency, R with two frequency. Then what I will do, I will take one letter of my string. Okay, let's suppose I am going here. It is prep. Okay, now I will take one letter of string P. Again, what I will do, I will find the difference P minus A again. P minus A. What is this? 50. What is the frequency of 50? 3. So simply move ahead. Because I can't pick up the n character that is the frequency of 3. Then R. What is the difference? 17. Move to 17. What is the frequency? 2. 12. 2. So simply move. So what I will do, I will check with O. What is the element index? 14. And simply move to 14. Okay. So here the frequency is 1. And that's what I want. So what I will do, I will simply print the indexes, and here the index is 0. 1, 2, 3, 4, 5, 6. That is 2. That will be my answer. Okay. So you can also apply this approach. Okay. So here again, time complexity, what it will be, basically what you are doing, you are simply iterating through the string length. So your number of iterations will depend on the length of the string. So the time complexity will be O of n, and your space complexity will be constant because you are taking a constant space that is an array of 26 characters. Okay. So that is also constant. So this is one of the approach that you can apply and solve this question. So now on the next video, we will see how we can implement this problem, how we can write the code of these two approaches.